factoring trinomials. All right, like I said, we've already factored before. This is a little different. Instead of trying to pull out a greatest common factor or trying to use the difference of perfect squares method, we will talk to you about how to factor trinomials. They'll be pretty easy when you're factoring a trinomial that has a 1 in front of x squared. They'll be a little bit more difficult when there's not. So let's all talk about where this comes from. So it comes from the fact that we multiply two binomials. So we're going to start there as a little review, and then we're going to show you how to work this backwards. So a quick review of what we did just a few classes ago. We took the first binomial, because it's a binomial, it has two pieces, broke it up into those two pieces, and multiplied it by the second one. So it looks something like this. We took the x, multiplied it by x plus 7. We took the -2 and multiplied it by x plus 7. We did that twice. I also showed a few of you how you can just distribute the x over the top and the -2 underneath. I'm going to go through all the steps here because I'm going to show you how we got to where we got. So here, x times x, that creates the x to the second power. Two x's put together is x squared. X times 7 is in fact 7x. Same thing we do here. -2 times x, -2x, -2 times 7, -14. And there you have it. Looks like we got 4 pieces. We will end in a trinomial 3 pieces because we're going to combine like terms. X squared is not like anything else, but 7 minus 2x is. That would be 5x minus 14. And there you have it. Just to recap all of this, remember that this came from addition. That'll be important later, this 5x. And the 14 came from multiplication, right? So there was a step where we multiplied and there was a step where we added. Put that in the memory banks. I'll come back to that in a little bit. So that's an easy one because this is a 1 here. Not always like that. Will not always be this easy when we have like 2x minus 3 and 5x plus 1. So let me take you through how we multiply these. Again, we break it up into 2 parts, separate it, and multiply it by 5x plus 1. So going through this rather quickly, 2x times 5x plus 1, and then -3 times 5x plus 1. I'm going to explain this kind of, remember we talked about last time, or this is kind of like a GCF here. This is kind of like a GCF here. And I kind of went backwards. Well, now I'm going to use distributive property and put it in. This will all make sense in a minute, I promise. So I'm going to take the GCF and put it in. And so now this is 2 times 5 for 10, x times x, x squared, and then 2x times 1, 2x. So clearly, we've put the 2x into both of those terms. And then over here, we're going to take the -3 and put it in. So that's going to be 3 times 5, -15, -3 times 1, -3. So I've again put a -3 in, so it had a greatest common term now. Going to go ahead and add these two in the middle here because those can be added. 10x squared minus 13x minus 3. And there you go. You've ended in a trinomial. And where are we going with all this today? We're actually going to start here and then create this situation. We're going to start with the trinomial, put it into 2 binomials. We're going to start with the trinomial, put it into 2 binomials. And I know how excited you are. The room just went crazy. All right. Question there. So good news about all of these ones. There is a 1 in front of every single one of these y squareds. You don't need to write it, other than you need to know the fact that if there's a 1 there, this could be very easily factored into 2 binomials. Okay, so get your sets down. We talked about what that is last time. And remember, the middle number is what we added to. The second number is what we multiplied to. Okay, and there you go. So we got 10 here. Ways we could multiply to 10. 1 and 10, 2 and 5. Now only one of those pairs successfully adds to 7. Which pair would do that? 2 and 5, right? 1 and 10 can add to 10. It can't add anything else. Sorry, add to 11. 11 can't add anything else. So x squared is a combination of x and x. And then we know that it's 2. We know that it's 5. Just be careful of signs. Both positive means both positive. Plus 2 plus 5. And that's it. You've worked it backwards. We go again, this time with the number 6, because we multiply to the second number, the one that's by itself, we add to the middle. So always start 1 and 6, or 1 and whatever the number is, and then think about other ways like 2 times 3. No need to write 3 times 2, it's the same thing. Get your 2 parentheses down, your binomials. X squared, x with x, the one pair that adds the 7. 1 and 6. So positive, positive, plus 1, plus 6. Not too shabby, right? All right. Take a look at number 3. We change the signs. -9, +8. Okay? So again, factor 8. Right ways to multiply to 8. 1 times 8, 2 times 4. Now this is a +8. The only way you multiply two numbers to a positive is if they have the same sign. But what do they add to? A negative. So these have got to both be negative. Okay? A negative times a negative will make a positive. They also add to a negative. So we get our binomials down. The letter doesn't matter. If it's b squared, it's still a couple of b's. But what is the pair that adds to -9? Okay, 1 and 8. So that's a -1, -1, and a -8, -8. Cruising right along here. Hopefully these are review. Gonna go ahead and just get my 2 binomials down. 20's got a few more factors than some of the other numbers we've seen. 1 and 20, 2 and 10, 3 no, 4 and 5. You can stop when you've got to the point where you're going to repeat yourself. Again, +20, signs must be the same. -9 means they're both negative. Same signs, both negative. Out of that list of pairs, 2 numbers is a pair, what's the only pair that would add to your middle number? You got it. Noah's on a roll here. So again, it was B and B, so -4 and -5. And we finish up with when we have a positive and a negative, and this is going to create different signs. So we know it looks like 2 binomials. We're trying to find the factors of 18, the number we multiplied to. 1 and 18 always starts at 2 and 9. Could also go 3 and 6. It's a little tricky here because it's a -18, which means our signs are different, which means it can kind of float. It can go with the 1 or it can go with the 18. It could be a -2 or a -9, -3 or a -6. They're just both not the same. So why here? Why here? We're trying to add to 3. Okay, 1 and 18, not going to do it. 2 and 9 can give you 11, can give you 7, but can't give you 3. So it's got to be 3 with 6. But here's where you have to be careful. It's a positive when you add it, negative when you multiply. So which one gets the positive and which one gets the negative? Bigger number is going to get the positive because it adds the positive. Smaller number gets your negative. Boom. All right. Go ahead, try the last one on your own. I'll be around to help anybody out if you got questions. So we know it's going to be 2 binomials. So put it down as 2 binomials. Y squared means it came from multiplying y and y. And ways we multiplied the 10. Could have been 2 and 5, 1 and 10. Key is it adds to a -3. So that means the bigger number gets the negative. So -5 and +2. This is called factoring by grouping, which basically works the problems backwards. So the problem that we just did early on, 10x squared minus 13x minus 3 was our answer. And if I can show you that, to believe me, right here, 10x squared minus 13x minus 3 is our answer. We're going to work it back to these 2 binomials by basically undoing this process. And notice the process, we're at a trinomial here. Then we were at 4 pieces, so you could say a quadrinomial. Then we had the GCF kind of like taken out. And then we put the binomials that were the same back together. Because I used this second one twice. I split it up. So we're just going to put those back together as 1. And that's kind of the reason why I showed you how to multiply that way. So let's go through this 6-step process. First thing we want to do is multiply the A and the C term together. So when we label these, this is the A, this is the B, and this is the C, right in that order. Because it's in standard form. We talked about standard form like the first day. So 10x squared minus 13x minus 3. So this would be 10 times negative 3, which is negative 30. Okay? So there's the number that you're going to have to factor. So we're going to factor 30. These get obviously a little bit bigger. So 1 times 30, 2 times 15, 3 times 10, 5 times 6. Same thing. We want to figure out the pair that will add to this middle number. Well, just to go through the list, again, these have to be different signs when your product is negative, so that's not going to happen. 2 and 15 could do it. 3 and 10 could do it, but definitely not 5 and 6. So how do you choose between 2 minus 15 giving us negative 13 and 3 plus 10 giving you 13? Well, in order for this to be negative 13, they both have to be negative. They have to be negative 3 plus negative 10. That's not going to happen because I got to have them multiply to a negative. So it's going to be 1 negative, 1 positive, and we found the correct pair. Only this pair adds to negative 13 and multiplies to negative 30 when the signs are such. Okay? So now that we've got the two numbers, we're going to rewrite this. So, we're going to keep the 10x squared. So we're going to keep 10x squared. Now I'm going to use my pair numbers, my two numbers, positive 2 and negative 15, to rewrite this 13x. So positive 2x minus 15x, and then it was still minus 3. So I went from 3 pieces, to 4 pieces based on what I knew. And kind of like if we went back to the very first one we did, we had 3, we went back to 4, and that's because I just figured out what this, how this was added. I realized that it was positive 2 and negative 15. Now, I will say it would be a good idea to put the negative number first, but not going to be a huge deal. Okay, now we use the associative property for a piece of candy. What property was this one? The associative. Well, it was kind of like when we, not the moving around, James, when we add in the groups, right? The parentheses. Kind of, Noah, kind of. So let's group these together. So we're going to go 10x squared plus 2x together. Group the first two. And then I got to put an addition sign because we're not multiplying yet. And then negative 15x minus 3. Okay? So I've grouped them. I've got 2 groups now. From these 2 groups, I want to find the greatest common factor. So when I look at 10x squared plus 2x, what is the greatest common factor? What is it that they have in common? A 2 and an x, right? And you know that because you watch me put it in. You watch me take the 2x, which I call the GCF, and put it in to make this. No surprise here. So we're going to then take it out. So 10 divided by 2 is 5. X squared, take away an x, is x. And then here's the tricky part. 2x divided by 2x is just 1. So there is just 1 left. You have to have that there. The other one, negative 15x minus 3. Let's go ahead and figure out what the GCF is, what we're taking out of that. Noah. 3, right? But a negative 3 too, because it's got to be equal to what we've got here. So negative 3 coming out. Divide that out of there so that it's 5x plus 1. And you should see a common binomial. All right, you see how this and this are the same? Again, I'm going to go back to what we did here. Remember when I took this one binomial and used it twice so I could multiply the 2x times the negative 3? There it is, the 2x and the negative 3 all put together. So I finally, if I wrote this out as one big thing, it'd be 2x minus 5 plus 1 minus 3, 5x plus 1. That's what it really would look like. I'm going to take this and this as 1, and then come back and put this back together. So there I have it. The whole thing back as the multiplication